Good evening, everybody. Now, let us start my today's class. So, today I will read about series expansion. Okay? Series expansions. So, in our series expansions, first we will say what is your Taylor series. Okay? So, now comes to what is your Taylor series. So, what is the statement of Taylor series? Let f of z be analytic. Let f of z be analytic in a region D. Analytic in a region D containing Z0. Okay. F of Z be an analytic function in a region D containing Z0. Then f of Z can be represented as a f of Z can be represented as a power series in Z minus Z0 can be represented as a power series in Z minus Z0 is given by f of z is equal to, this is f of z0 plus f dash z0 divided by 1 factorial whole into, this is z minus z0 plus f double dash at z0 divided by 2 factorial whole into z minus z0 square plus dot 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 like this up to f nth derivative at z0 divided by n factorial whole into z minus z0 to the power n plus dot dot up to infinity. This expansion is valid. This expansion is valid in the largest open disk. In the largest open disk with center z0, with center z0 containing in D. Containing in D. Okay. So what is the Taylor series? Let f of z be analytic. F of z be analytic function in a region D containing z0. Then f of z can be represented as a power series in z minus z0 is given by f of z is equal to, this is the Taylor series expansion of f of z about this point z0. Okay. So here f of z is equal to f of z0 plus f dash z0 by 1 factorial whole into z minus z0 plus f double dash z0 by 2 factorial whole into z minus z0 square plus dot 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 plus f nth derivative at z0 by n factorial whole into z minus z0 to the power n plus dot 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 like this. And this expansion is valid in the largest open disk with center z0 containing in D. Or in general, I will write this is the non-negative power of z minus z0. I can add this is a modulus of z minus z0 is less than 1. This is the region where this expansion is convergent. Also, you may note that a Taylor series expansion of f of z, a Taylor series expansion, a Taylor series expansion of f of z is about a point z0 where the function f of z is analytic. Where the function f of z is analytic. Okay, that means Taylor series, we can say Taylor series of the expansion of f of z, or the Taylor series expansion of f of z about the point z0. That means it says that or you can say that f of z must be analytic at that point z naught. Okay, and what is the Taylor series expansion? And this expansion is the non-negative powers of z minus z naught. Okay, and this is valid. This expansion is valid in some neighborhood of z naught. So this is our Taylor series. And then what is I am not going to prove it. Then what is a Maclaurin series? Then comes to what is a Maclaurin series. So Maclaurin series is a special case of Taylor series expansion, which says that this is the series expansion above the point 0. Okay, so I can say Maclaurin series is a special case of Taylor series expansion. Is a special case of Taylor series expansion where the expansion is above the point z is equal to 0. Okay, that means we can say that Maclaurin series is the Taylor series expansion. This is the Taylor series expansion above the point z is equal to 0 is given by f of z is equal to, this is f of 0 plus z by 1 factorial f dash 0 plus z square by 2 factorial f double dash at 0 plus dot 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 like that to the power n by n factorial f nth derivative at 0 plus dot dot dot. Okay, so this is the Maclaurin series expansion. So if you will do some problem, first I will do a problem. Example 1. The Taylor series for f of z equal to 1 by z above z equal to 1. Find the Taylor series expansion and the Taylor series expansion of 1 by z above the point z equal to 1. Okay, this is my question. So now how we will solve it. So here the function is this one, and this is above the point z equal to 1. That means the power series, or you can say the power series is above the or there you will get a series where the non-negative terms are, where the terms are the non-negative powers of z minus 1. Because z is equal to 1, then z minus 1 is equal to 0. So we have to find the expansion where the non-negative terms of z minus 1 will occur. Okay? Or this is the power series above z is equal to 1 means we will get the non-negative powers of z minus 1, like z minus 1 to the power 0, z minus 1 to the power 1, z minus 1 to the power 2, z minus 1 to the power 0 is 1, so 1, z minus 1, z minus 2 whole square, like this type of powers will come. Okay, so now we can write what is our Taylor series expansion. We have the Taylor series formula. We have the Taylor series formula. F of z is equal to, this is the Taylor series formula. F of z is equal to, our Taylor series formula about the point z naught. This is your f of z naught. Taylor series formula about the point z equal to z naught is given by f of z is equal to f of z naught plus f dash z naught by 1 factorial whole into z minus z naught plus f double dash z naught by 2 factorial whole into z minus z naught square plus f triple dash at z naught by 3 factorial whole into z minus z naught cube, like this. Okay. So here f of z is, here f of z is your 1 by z and your z naught is 1. Okay, because this is about the point z equal to 1. So since your f of z is 1 by z, then what is your f dash z? F dash z will be minus 1 by z square. So your f dash z naught, which is your f dash 1, so this will be minus 1. Similarly, f double dash z, this will be minus, is the derivative of f dash z, this will be 2 by z cube, then f double dash at 1 or f double dash at z naught, this is your 2. Similarly, f triple dash z, this will be minus 6 by z4. So f triple dash at 1, this will be minus 6. Okay, similarly, these are the things. Okay, you can also evaluate what is your f of 1. If f of z is your 1 by z, then f of 1 is your 1. Then f dash 1 is your this one. F double dash 1, this is your this one. And there f triple dash 1 is this one. So now I will put this thing here. In place of z naught, I will put 1 and this thing. So let it be your equation 1. So equation 1 implies f of z. F of z means your 1 by z. So this thing will be f of z naught. F of z naught is your 1 plus f dash z naught by 1 factorial. F dash z naught, this is your minus 1. So this one plus minus 1 whole into z minus 1. Then plus f double dash z naught by 2 factorial. So this will be 2 by 2 factorial means this is 2 whole into z minus 1 whole square. Then plus f triple dash z by 3 factorial. F triple dash z is your minus 6 by 3 factorial. Okay, so minus 6 by 3 factorial means it is 6. This is z minus 1 cube plus dot dot dot. Okay, so if you will simplify, here we will get 1 minus z minus 1 plus z minus 1 square minus z minus 1 whole cube plus dot dot dot. So this is the Taylor series expansion of 1 by z about z is equal to 1. Okay, so now comes to another problem. So problem number 2, expand cos z, expand cos z into a Taylor series about the point, into a Taylor series about a point, z is equal to pi by 2 and determine the region of convergence, and determine the region of convergence. Okay, so now we'll solve it. So here f of z is equal to cos z, then this is about this point pi by 2. So if f of z is your cos z, then what is f of pi by 2? This will be cos 90 0. Then what is your f dash z? So f dash z is cos z's derivative. This is minus sin z. So f dash at pi by 2, this will be, so this will be minus 1. Similarly, f double dash z, derivative sin z is cos z, then this will be minus cos z. So f double dash at pi by 2, this will be again 0. Then if I will calculate f triple dash of z, then this will be sin z. Then f triple dash at pi by 2, this will be 1. Similarly, fourth derivative of f of z, this will be cos z. Again, this value at pi by 2, this will be 0. And similarly, we will evaluate this thing. And then, so here f of z is equal to this one. And we can say our z naught is pi by 2. So now I will write the formula. The Taylor series formula of the Taylor series expansion. You can say the Taylor series expansion. The Taylor series expansion about z equal to z naught is given by f of z is equal to, this is the f of z naught plus f dash z naught by 1 factorial whole into z minus z naught plus f double dash z naught, sorry, f double dash z naught by 2 factorial whole into z minus z naught square plus f triple dash z naught by 3 factorial whole into z minus z naught cube, like this. So what is your f? Z naught is your pi by 2. So f of pi by 2, this is 0. So this is 0 plus f dash z naught, this is your minus 1. So minus 1 whole into z minus z naught. Z naught is your pi by 2. So this is z minus pi by 2. Then f double dash z naught, f double dash pi by 2 is your 0. So 0 into something will be 0. I will not write that thing. Then f triple dash z naught, this is your 1. So then this is 1 whole into or 1 by 3 factorial whole into z minus pi by 2 to the power 3 plus dot dot dot. Then what I will write, this will be minus of z minus pi by 2 plus 1 by 3 factorial of z minus pi by 2 cube. Similarly, if I write the next term, this will be 1 by 5 factorial. This is z minus pi by 2 to the power 5, like this. So all terms will appear, and there is alternatively negative and positive signs are there. Okay. So this is the Taylor series expansion of cos z. Taylor series expansion of cos z about the point z is equal to pi by 2. So now comes to another problem. So expand f of z. Okay, then what is the region on that thing? The region, the expansion is valid throughout the whole complex line. Because cos z is analytic everywhere. Since cos z is analytic everywhere, so we can say that the expansion is valid. Here the region is asking here. So we can say the expansion is valid throughout the whole complex plane. Okay. So now we'll write and now we'll solve. Expand f of z is equal to z minus 1 divided by z plus 1 as a Taylor series. As a Taylor series above the point z is equal to 0, above the point z is equal to 0, and also there is a second bit above the point z is equal to 1, above the point z is equal to 1, and also determine the region of convergence in each case. Determine the region of convergence in each case. Okay, first I will make the series expansion of this given problem about z is equal to 0. Then second I will make the Taylor series expansion about z is equal to 1. Then in each case I will find what is the region of convergence. Okay. So now constant solution. So here f of z is equal to z minus 1 divided by z plus 1, and in the first case it is asking about z is equal to 0. So z equal to 0 means uh, in the power series, so what you will get? You will get the non-negative powers of z minus 0. That means the non-negative powers of z. So what are the non-negative powers of z? So this is z to the power 0, z to the power 1, z to the power 2, z to the power 3, like this. Z to the power 0 means this is 1. So 1 z, z square, z cube, z4. So these are the powers will come. So you have to expand this one such that you will get the powers of these things or powers of z. So what I will write this thing, this is z minus 1 and this is 1 by z plus 1. I can write this one as 1 divided by 1 plus z, z plus 1, 1 plus z both are same, and this is you can know what is the series expansion. You already know what is the expansion of 1 minus 1 divided by 1 plus z. This is 1 minus z plus z square minus z cube plus dot dot dot, such that uh, you can say where more z is less than 1. Okay, this expansion is valid if more z is less than 1, and this is the region of convergence you will get. So what is the extension of this one? After multiplication, what you will get? This is z minus z square plus z cube minus z4 plus dot dot dot. Then also multiply minus 1. Then this is minus 1 plus z minus z square plus z cube minus dot dot dot. Then if you will rearrange, this is first I will write this minus 1. Then this is z, so this will be 2z, then this is minus z square, so minus 2 z square, then here it is z cube, this is also z cube, so this is plus 3 z cube. Similarly the next term will be 4 z4. So similarly all the terms you can write. Sorry, this is minus 1, then this is z, so this will be plus 2z, then minus 2z square, then this is plus 2z cube, this is z cube, this is again z cube, so this is plus 2z cube, this is also minus 2z4. So everywhere 2 is here and alternately positive negative signs are there. So on the region of convergence is, you can write here the region of convergence is more z less than 1. Okay. Now we'll go to the next bit. This is saying about the point z is equal to 1. So in the second about the point z equal to 1 means, so all these things will be the non-negative powers of z minus 1. So what are the non-negative powers of z minus 1? you can say this is z minus 1 to the power 0, z minus 1 to the power 1, z minus 1 to the power 2, then z minus 1 to the power 3. All these things will come. That means this is 1, then z minus 1, z minus 1 whole square, z minus 1 whole cube, and like this. So all these powers will come after the expansion. So now I will make this one in terms of z minus 1. So now I will solve. So for second bit I can write my f of z is equal to, this is z minus 1 divided by z plus 1, and my aim is to get z minus 1. So I can write this is z minus 1, it is okay. So if I will write z minus 1 here, but this is given that this is z plus 1. So if I will write plus 2 here, then you will get this is z minus 1. Then what I will do in the next step, I will take 2 common, such that I will write this is 1 plus z minus 1 divided by 2. So after writing this one, you know what is the series expansion of this one. I can write this one as z minus 1 divided by 2 whole into, this is 1 divided by 1 plus z minus 1 by 2, and I can use its series expansion if z minus 1 by 2 modulus is less than 1, or I can say this is z minus 1 modulus is less than 2. So this is my region of convergence. Okay, because wherever I am writing 1 plus 1 by x series expansion, this is 1 minus x plus x square, like this. Here, always I am saying that mod x, whatever I am writing, it is 1 plus x or 1 minus x. This mod x should be less than 1. This is the region of its convergence. So, whatever I am writing, this is 1 plus this one. So, this must be less than 1, and this is its region of convergence. So, I can write that one as, this is z minus 1 by 2 on the left hand side. Then what is the series expansion of 1 divided by 1 plus z minus 1 by 2? This will be 1 minus z minus 1 by 2 plus z minus 1 by 2 whole square minus z minus 1 by 2 whole cube, plus like this. Alternatively, plus minus signs are there. So then what I can write, then if I will multiply this z minus 1 by 2, then what we will get, this will be z minus 1 by 2 minus z minus 1 by 2 whole square, then plus z minus 1 by 2 whole cube, then z minus 1 by 2 to the power 4, like this. Okay, on the region of convergences, here you can say the region of convergence is z minus 1 divided by 2 modulus is less than 1, or you can say this is z minus 1 modulus is less than 2. If I will multiply 2 on both sides, then this thing I will get. Similarly, go to another problem. So that so that 1 by z square is equal to 1 plus summation of n from 1 to infinity, summation of n from 1 to infinity, n plus 1 whole into, this is n plus 1 whole into z plus 1 to the power n, z plus 1 to the power n, when z plus 1 modulus is less than 1. And secondly, we have to show that 1 by z square is equal to 1 by 4 plus 1 by 4 whole into summation of n from 1 to infinity. This is minus 1 to the power n whole into, this is n plus 1 whole into z minus 2 divided by 2 to the power n, when z minus 2 divided by 2 modulus is less than 1. This thing divided or you can say z minus 2 modulus is less than 2. This thing is less than 2. That means I can write this one as z minus 2 divided by 2 modulus is less than 1. Both are same. Okay. So if this thing is given, we always want to write 1 on right hand side. That's why I will divide 2. That's why I will get this one z minus 2 by 2 whole modulus is less than 1. So now we'll solve the first one. The first one is saying all the powers will come in z plus 1. That means z plus 1 to the power 0, which will 1, and then z plus 1 to the power 1, z plus 1 to the power 2, z plus 1 to the power 3. So I will make here z plus 1. So it is given that this is 1 by z square. So I want to write in terms of z plus 1. So I will write in z plus 1. So since z is here, so what I will write? I will write this is 1 minus z to the power 2, such that sorry, this is 1 minus z plus 1, 1 minus z plus 1, then whole square. So I can write this one as this is 1 minus of z plus 1 whole square. Okay, then after opening this bracket, you will get this is 1 minus z minus 1. So 1 minus 1 will cancel out, then minus z whole square, which is z square. So why you do this thing? Because we need z plus 1 in the expansion. So whatever the z it is given, I need to write it first z plus 1, then I will balance it, or I will make it in such a way such that it will be equal to 1 by z square. So this is the one way I can write. This is 1 divided by 1 minus z plus 1 whole square. So this is the crucial step. Why I am writing this is in terms of z plus 1, because it is given that z plus 1 modulus is less than 1. That means the series expansion is about z plus 1. Okay, that's why I am making this thing in terms of z plus 1. So what is the series expansion of this one? We know this thing, 1 divided by 1 minus x, 1 divided by, what is the series expansion of 1 divided by 1 minus x whole square? This is here 1 plus 2x plus 3x square plus 4x cube, like this, where mod x is less than 1. So what will be the series expansion of this one? Or you can say this is 1 minus z plus 1 to the power minus 2. So its series expansion is 1 plus 2 whole into z plus 1 plus 3 whole into z plus 1 cube, sorry, z plus 1 square plus 4 whole into z plus 1 cube, like this, where z if z plus 1 modulus is less than 1. And if you will write this by using summation formula, you can write this is 1 plus summation of n from 1 to infinity. This will be n plus 1 whole into z plus 1 to the power n. This is the answer, and the region is z plus 1 modulus less than 1. Similarly, if we will go to the next one, the same question. This is 1 by z square, and I have to write this in this way, or I have to write the by using Taylor series expansion. I will write 1 by z square as this one when z minus 2 modulus is less than 2. So z minus 2 modulus is less than 2 means z minus 2 divided by 2 is less than 1, and that means I have to make the expansion of this the given function as a power series of z minus 2 divided by 2. Okay, so z minus 2 first I want to get this thing. So I can write this 1 by z square in place of z. If I write this is z minus 2, so how I will balance this thing? So if I write z minus 2, then I will write a plus 2. then whole square, then if minus 2 plus 2 can cancel out, then it will be your z square simply. So this step is crucial. So after making this step, then you will write how you will get z minus 2 by 2. So to get this thing, I will take 2 common, then this will be 1 plus z minus 2 by 2. Okay. Now after this thing, you may proceed. So whatever I will write this thing, this is 1 by 4 whole into this is 1 plus z minus 2 divided by 2 to the power minus 2. Then I can expand that one like previously. So 1 by 4 whole into this is 1 plus, sorry, there is minus, alternatively plus minus, then 1 minus this is z minus 2 by 2, then z minus 2 by, sorry, 1 minus 2 times this thing, then plus 3 times this one square, then minus 4 times this is z minus 2 divided by 2 whole cube, like this. So whatever I am writing, 1 divided by 1 minus x square, similarly 1 divided by 1 plus x whole square, this is your 1 minus 2x plus 3x square minus 4x cube plus dot dot dot. Okay. If the expansion 1 plus whatever I am writing, this is 1 plus this thing must be less than 1, its modulus. This is z minus 2 divided by 2 modulus is less than 1. That means this is z minus 2 modulus is less than 2 after multiplying 2. So this is the expansion. So if I will write this thing in summation form, or if I will multiply first 1 by 4 with this bracket, so I will write this is 1 by 4, then this is 1 by 4 into 2 times this one, then 2 can cancel out, then I can write this is 1 by 4. Okay, whatever is there I will write this thing 1 by 4 into 2 times this is z minus 1 by 2, then this will be 1 by 4 into 3 times z minus 1 by 2 whole square, then minus 1 by 4 into 4 times this is z minus 1 by 2 whole cube plus like this. So if I write it in summation form, I will write this is 1 by 4 plus 1 by 4 whole into, because everywhere is 1 by 4 is there, so I can take 1 by 4 common, then I will write this is n from 1 to infinity. This is minus 1 to the power n, because alternatively plus minus n's are there. Minus 1 to the power n whole into n plus 1 whole into z minus 2 divided by 2 whole to the power n. And the region of convergence is, this is z minus 2 divided by 2 modulus is less than 1, or you can say this is z minus 2 modulus is less than 2. Okay. Uh, then comes to another problem. So if I will do another problem, that is problem number 5, say expand z e to the power 2z, z e to the power 2z, z e to the power 2z in Taylor series expansion, in Taylor series, Taylor in Taylor series expansion about z is equal to minus 1, and determine the region of convergence, and determine the region of convergence. Okay, so its solution will be, since it is saying that the series expansion about z equal to -1, that means your z plus 1 equal to 0. So my expansion will be in terms of z plus 1. Okay, so whatever the terms will come, that will be the non-negative powers of z plus 1. Okay, that means z plus 1 to the power k, where k is greater than equal to 0. Okay, all the terms will be the powers of non-negative powers of z plus 1. So how I will write this thing? So here f of z is z e to the power 2z. So I want to write in place of z, everything will be in z plus 1. So in the first step, if I will write this is z whole into e to the power 2 whole into z plus 1. Then for balancing it, I will write this is e to the power minus 2, because e to the power 2z is here, and I am writing in place of z it is z plus 2. So extra e to the power 2z will be e to the power 2 will be there. Then I will multiply e to the power minus 2 so that it will balance. So then it will be 1 by e square whole into z into e to the power 2 whole into z plus 1. Then again there is a term z, so I can make the balance, or I, in place of z, if I will add z plus 1, then after writing I will balance it. So if I will write here z plus 1, then it is e to the power z plus 1. Then since I am writing here z plus 1, so for making its balance, I will subtract here e to the power 2 times this is z plus 1, so that it will balance. But I have to write this is z plus 1 because all my expansion will be in powers of z plus 1. That's why I am trying to get this z plus 1 term. Okay, so then what I will write, this will be 1 by e square, then this is z plus 1. Then what is the expansion of, we know already the expansion of e to the power z, this is z, sorry, first I will write 1, then z plus z square by 2 factorial plus z cube by 3 factorial, like this. So this will be z plus 1, here it is given. Then e to the power 2 z plus 1 can be written as, this is 1 plus 2 whole into z plus 1 by 1 factorial, then 2 whole into z plus 1 whole square by 2 factorial, then 2 whole into z plus 1 whole cube by 3 factorial plus dot dot dot. Similarly, here is minus e to the power this one. Then for that one, I will write this is minus of, in curly bracket I will write the expansion of this one. So this is 1 plus 2 whole into z plus 1 by, sorry, 1 factorial. This one by 1 factorial. Then plus 2 whole into z plus 1 whole square by 2 factorial. Then plus 2 whole into z plus 1 whole cube by 3 factorial, like these things. Then bracket closed. Then what I will write, if I will simplify this one, I can write this is 1 by e square. Then I will multiply this z plus 1 in each term. Okay, so this will be z plus 1 plus 2 times z plus 1 whole square by 1 factorial. Then plus I can write this is 4 times, or you can say this is 2 square, 2 square z plus 1 whole cube by 2 factorial. Then this is 2 cube z plus 1 whole 4 by 3 factorial plus dot dot dot, and there is also minus of these things. I will not open this bracket. Then minus of whatever it is written, 1 plus 2 times this is z plus 1 by 1 factorial, 2 whole into z plus 1 whole square by 2 factorial plus dot dot dot. Okay, so then I will add this is 1 by e square whole into, then this is z plus 1. Okay, first here it is 1, so I will write minus sign is here. So I will write this is minus 1, then this is z plus 1. I am writing in ascending powers or in ascending order. So this is z plus 1, and there is also a z plus 1. So I can write it as this is 1 times z plus 1, this is minus of, so this is 1 minus of 2 minus of 2 whole into z, 2 by 1 factorial whole into z plus 1. Similarly, this is z plus 1 square, this is also z plus 1 whole square. So I can write this one 2 by 1 factorial minus 2 square by 2 factorial. 2 square by 2 factorial whole into z plus 1 whole square. Similarly, for third term, you can write this is 2 square by 2 factorial minus 2 cube by 3 factorial whole into z plus 1 whole cube. So this will continue like this, and this expansion is valid for whole complex plane because e to the power z is an entire function and it is analytic everywhere in C. Thus we can write the expansion because the sine, cos and e to the power z, all these things are entire functions, so these are valued in whole complex plane. These are valued in whole complex plane. Okay, so now comes to next problem. This will be your last problem. So what is the problem? Find the Taylor series. Find the Taylor series expansion, or find the Taylor series to represent. Find the Taylor series to represent z square minus 1 whole divided by z plus 2 whole into z plus 3 in mod z less than 2. In mod z less than 2. Okay. So what is the region of convergence mod z less than 2? That means this is z by 2 mod is less than 1. Okay. So that means I will expand this thing in such a way that z minus 2 will be always less than 1. So try to get this thing. So by partial fraction, we have z square minus 1 whole divided by z plus 2 whole into z plus 3. This thing can be written as, you know how to use your by parts. So by using the by parts of this partial fraction, this thing can be written as 1 plus 3 divided by z plus 2 minus 8 divided by z plus 3. Okay, you have to verify this thing. Then whatever I will write the next step, this will be 1 plus to get z plus 2. So here I will take 2 common such that this will be 1 plus z by 2. And here we don't need to get this z plus 2. If I will take here 3 common, then this will be 1 plus z by 3. And you know, if z by 2 is less than 1, and here the series expansion will be z by 3. So if z by 2 is less than 1, then obviously z by 3 is also less than 1, modulus of z by 3. Okay, because z by 2 is this, z by 2 is always less z by 3. This thing is always less than z by 2. And since z by 2 is less than 1, so obviously z by 3 is less than 1, so this expansion will be valid. So whatever will be series expansion, then 1 is like this, then 3 by 2, then what is the series expansion of 1 divided by 1 by z plus 2, this will be 1 minus, this is z by 2, then z by 2 whole square, alternatively plus minus signs are there, so this is z by 2 whole cube like this, then minus 8 by 3 times. Similarly, this one 1 minus z by 3 plus z by 3 whole square minus z by 3 whole cube, like this. Okay, so if I will combine, or if I will write in the ascending power subject, first I will write the constant. This is 1, then this is 3 by 2, or 3 by 2 times this is 1, then this is minus 8 by 3 times 1. So this will be my constant term. So then if I will gather my powers of z, then z by 2, then this is 3 by 2. So this will be minus 3 by 2 square, then this is minus 8 by 3, then this is minus z by 3. So this will be plus 8 by 3 square into z. Similarly, for z square, I can write this is 3 divided by 2 into 2 square minus 8 divided by 3 into 3 square whole into z square. And similarly, it will be like this. So what will be this one? This is minus 1 by 6 plus n from 1 to infinity. Then if we will observe, you will get this will be minus 1 to the power n plus 1 whole into 8 divided by 3 to the power n plus 1 minus 3 divided by 2 to the power n plus 1 whole into z to the power n whole into z to the power whole into z to the power n. So this is the answer you will get. Okay, there are more questions, you can solve it. So today is only this much. Thank you.